We often think of communication as something exclusive to humans: spoken words, written language, even emojis on a screen. But beyond our limited senses, nature is humming with countless conversations happening every second. From the forest canopy to the ocean floor, animals are exchanging messages in ways that defy our expectations. What if we told you that ants use invisible chemical trails like secret messages, or that elephants can speak using frequencies so low we can't even hear them? This is not just science, it's an alien world of language, hidden in plain sight. Most of these forms of communication are completely outside the realm of human experience. Imagine using your entire body as a signal, or sending messages with flashes of color, electric pulses, or even vibrations through the ground. Some animals communicate silently, others use thunderous displays. Some send messages across great distances, while others whisper so subtly that only their own kind can detect them. Yet all of these methods are precise, intentional, and crucial for survival, guiding everything from hunting and mating to warnings of danger. In this video, we're going to explore the most fascinating and unexpected ways animals talk to one another. You'll learn about creatures that use color changes to express emotion, birds that mimic other species to deceive, and even fish that light up the ocean with their own built-in flashlights. These aren't just fun facts, they challenge everything we thought we knew about intelligence, adaptation, and what it means to have a voice. Get ready to see the animal kingdom in a way you've never seen before. Subsonic messages of elephants. Elephants are some of the most socially complex creatures on Earth. They not only form tight family groups but also maintain bonds with distant relatives. To do this, they've developed a form of communication that is nearly invisible to the human ear. Elephants use infrasound, low-frequency sounds that travel through the air and even the ground over vast distances. These calls can travel several kilometers, allowing separated herds to stay in touch or warn others of threats like poachers or predators. This form of subsonic messaging is more than just noise, it carries complex emotional and situational content. Elephants can communicate urgency, location, intent, and even identity through slight modulations in their rumbling calls. Some researchers believe they may even have names for one another. Scientists have recorded mother elephants calling specific rumbles that prompt only their calves to respond, hinting at personalized signals akin to individual names. What makes this form of communication especially surprising is how it travels. Elephants can detect infrasound not just through their ears but also through their sensitive feet. They pick up vibrations in the ground caused by distant calls, which are transmitted up their legs and interpreted through specialized receptors. This means elephants are essentially hearing with their feet, an adaptation almost entirely unique in the animal kingdom. The implications are staggering. If elephants use complex long-distance communication, and if they respond emotionally to these signals, we are talking about a level of intelligence and connection comparable to early human communities. It's no wonder that when an elephant mourns, the entire herd seems to feel the loss. Their messages are more than noise, they're echoes of memory and emotion across the savanna. The secret chemical language of ants. While elephants communicate across great distances, ants do the opposite. They operate with astonishing precision in extremely close quarters. Lacking vocal cords or hearing, ants rely on a chemical language called pheromones to interact. These invisible scent trails are their equivalent of written signs, guiding others toward food, danger, or the nest itself. When a scout ant finds a breadcrumb, it marks its path back home with a specific pheromone. Others follow this trail, reinforcing it with each trip, creating a superhighway of scent. But it doesn't stop there. Different pheromones mean different things. Some signal alarm, triggering immediate defensive behavior. Others indicate death, prompting undertakers to remove a fallen comrade. Some pheromones even manipulate behavior, like when a queen ant secretes a chemical that suppresses fertility in other females, maintaining her dominance in the colony. To humans, these chemical cues are completely undetectable. To ants, they are precise, powerful commands. This form of communication is lightning fast and highly effective, despite lacking any sound or visual cues. It also shows just how deeply social and cooperative ants really are. Every ant in a colony knows its job not because it was told, but because it was chemically cued. This decentralization makes ant societies resilient and flexible, capable of responding to crises or opportunities with remarkable unity. In many ways, ants are proof that communication doesn't need to be loud or complex to be effective. Their scent-based messaging system is so advanced that it rivals, and in some ways surpasses, our own systems of organization. Next time you see a single file line of ants, know that you're witnessing a silent, invisible conversation in progress, unfolding with perfect coordination. The light signals of deep-sea creatures far beneath the ocean's surface, where sunlight never reaches, some of the most bizarre and ingenious forms of communication evolved. Here, in the pitch-black abyss, bioluminescence is the language of survival. Creatures like the anglerfish, lanternfish, and firefly squid emit light from special organs to attract mates, find prey, and warn off predators. It's a glowing conversation in the darkness. Every flicker, blink, and flash tells a story. These lights aren't random. Each species has specific flash patterns, colors, and rhythms that act like Morse code under the sea. For example, certain squid can produce pulses of light along their bodies in sequences, much like turning on rows of Christmas lights. Others, like the flashlight fish, have a sort of shutter they can open and close over their glowing organs to communicate with potential mates or confuse enemies during a quick escape. But what makes this form of communication even more fascinating is how deeply it's intertwined with deception. Some predators mimic the bioluminescent patterns of harmless species to lure prey into ambush zones. Others flash false signals that resemble mating calls. It's a constant battle of light and lies, where flashing too much could mean dinner or death. Bioluminescence is a perfect example of evolution tailoring communication to an environment's limitations. With no light, animals created their own. And in doing so, they turned the ocean into a living, blinking canvas of messages. For these animals, every glow is a voice, every sparkle a strategy, and every flash could change their fate. The colorful conversations of cephalopods, like octopuses, squids, and cuttlefish, are the undisputed masters of visual communication. With skin capable of instant color changes, they don't just hide from predators, they send messages to one another in real time, like living screens. These changes aren't just camouflage, they're part of a complex language of emotion, status, and intention. A cuttlefish can flash zebra-like patterns to show aggression, or wave flowing ripples across its body to soothe or seduce. Underneath their skin are thousands of specialized cells called chromatophores, each containing pigments that can expand or contract. By controlling these with their nervous system, cephalopods produce stunning patterns and color shifts in milliseconds. Some can also manipulate iridophores and leucophores, cells that reflect and scatter light, creating shimmering or even polarized effects that only certain species can see. This silent, visual dialogue is especially important during mating rituals and territorial disputes. For instance, a male cuttlefish may display a split body signal, showing one color to a female while flashing another side of his body toward a rival. It's a strategy that lets him seduce and warn simultaneously, playing both sides in a biological game of chess. The intelligence required to master this kind of communication is staggering. Cephalopods don't just react, they plan, adapt, and often deceive. Their color displays are not just instinctual patterns, they're deliberate signals based on context and memory. In other words, they're thinking, expressive animals whose language is written in color and light. The dance language of honeybees. When honeybees discover a rich source of nectar, they don't just keep it to themselves. They perform an elaborate dance inside the hive that directs others straight to it. Known as the waggle dance, this figure-8 movement is one of the most fascinating examples of symbolic animal communication. The duration and angle of the dance encode precise information about the direction and distance of the food source in relation to the sun. Bees observing the dance interpret this information and fly off in the exact indicated direction, sometimes over several kilometers. What's remarkable is that this system works without sound, scent, or sight of the actual food, just through motion and rhythm inside the dark hive. It's as if the bee is drawing an invisible map in the air, and the others are instantly able to read it. The waggle dance is more than just a tool for foraging. It strengthens the social bonds of the hive and ensures the survival of the entire colony. Some researchers believe bees even include information about food quality in their dance. The more enthusiastic the movement, the better the food. This makes it not just a map, but a review system. This discovery revolutionized our understanding of non-human intelligence. Bees, with brains no bigger than a pinhead, are capable of abstract communication, symbolic representation, and perhaps even cultural transmission of knowledge. In their tightly knit society, the dance is not art, it's life-saving direction passed on through movement and memory. Sonic trickery in songbirds' birdsong might sound like simple background music to us, but in the world of birds, it's a rich and nuanced language. Some species use songs to mark territory, attract mates, or warn of predators. But the truly unexpected twist is how some birds manipulate sound like skilled vocal artists. Species like the lyrebird can mimic chainsaws, car alarms, and even other birds' calls, not just for fun, but as a strategy. These vocal impersonations can mislead competitors or even confuse predators, showing a level of acoustic trickery that rivals human ventriloquism. In social songbirds, vocal learning is a vital part of communication. Young birds learn specific dialects by mimicking adults, creating regional accents across different populations. A zebra finch in one region may have a noticeably different song from its counterpart elsewhere, and this matters. Female finches often prefer mates who share their dialect, suggesting that vocal familiarity is tied to trust and bonding. Beyond mimicry and mating calls, birds also use alarm calls with astonishing specificity. Some can signal not only that danger is near, but what kind: a hawk overhead versus a snake on the ground. Other birds respond to these calls even if they're from different species. This cross-species understanding hints at a broader, avian internet of information sharing, where survival depends on paying attention to your neighbor's warnings. The complexity of bird communication shows how evolution has shaped not just feathers and wings, but entire cultural systems. Birds may not speak in words, but their songs are layered with meaning, intent, and sometimes deception. When a bird sings, it's not just making noise, it's broadcasting a message into a living, listening world. Vibrations in the web. How spiders signal. Spiders may seem like silent, solitary hunters, but for many species, communication is constant, and it's conducted through vibrations. When a spider builds a web, it creates more than just a trap, it's a finely tuned communication device. Male spiders send complex vibratory signals through the strands to court females, using a kind of love tap rhythm that distinguishes them from prey. If the female approves, she stays still; if not, he might become lunch. These vibrations aren't limited to mating. Some spiders use different rhythms to warn competitors or to fake prey movements, luring rivals into traps. The sensitivity of a spider's legs to these minute vibrations is extraordinary. Some can detect the exact weight and movement pattern of a trapped insect from meters away, simply by the feel of the web's tremble. For web-building species, the web itself is an extension of the body and a tool of expression. In fact, the shape, tension, and placement of threads can vary based on mood, hunger level, or even recent encounters. Some spiders adjust their webs nightly based on what worked, or didn't, the day before. This suggests an ability not just to sense but to evaluate and respond. It's a quiet, tremble-based language that has evolved in total silence. To a spider, each tiny pulse of movement is a word in a dialogue that determines life or death, mating or escape. In the stillness of a dewy morning web, there's more happening than meets the eye, an entire conversation written in silk and motion. Electric fields in aquatic communication. In murky waters where visibility is low, some fish have developed an electrifying way to communicate, literally. Species like the electric eel and the elephant nosefish generate and detect electric fields to navigate, hunt, and most surprisingly, to talk. These electric pulses act like underwater telegrams, encoding information about identity, intent, and emotion. Short bursts can mean alarm, while longer pulses might signal courtship or territorial boundaries. This method, known as electrolocation in electrocommunication, bypasses the limitations of sight and sound. These fish constantly emit low-voltage electric fields and detect distortions in them caused by nearby objects or other animals. But when another electric fish enters the zone, the game changes. it becomes a conversation of pulses, frequency shifts, and timing patterns. What's truly fascinating is how individualized these electric signals can be. Just as no two voices are alike, each fish has a unique electric signature. This allows members of the same species to recognize one another, or to avoid rivals. Some fish can even alter their signal temporarily to avoid jamming another's frequency, a phenomenon known as the jamming avoidance response. Electric communication is a powerful reminder that messages don't have to be heard to be understood. In these dark, silty environments, a flicker of electricity becomes the language of survival, an invisible network of pulses transmitting every desire, fear, and warning beneath the surface. The physical signals of primates, our closest relatives in the animal kingdom, communicate with a wide range of sounds, gestures, and facial expressions, many of which we can instinctively understand. A chimpanzee's grin may look friendly, but it's often a sign of submission or fear. A raised eyebrow, a pointed finger, a chest beat, these are not just actions, but deliberate signals used to influence group behavior. Their communication blends vocalization with body language in a way that mirrors early human interaction. In baboons and macaques, grooming isn't just hygiene, it's political. Who gets groomed, and for how long, reflects alliances, status, and reconciliation. These silent acts of social negotiation maintain group cohesion and prevent conflict. It's communication without a single word, but with heavy implications for survival and power dynamics. Some primates even use tools and gestures to pass on learned behavior. In orangutans, for instance, mothers teach their young how to use leaves as gloves or tools, and they do so with clear intent and repeated modeling. This transfer of knowledge is a form of cultural communication that extends far beyond simple instinct. But what sets primate communication apart is its emotional depth. When a gorilla mourns the death of a companion or a mother clings to her stillborn infant, we see expressions of grief that parallel our own. Their gestures and expressions aren't just signals, they're glimpses into minds that feel, remember, and connect. Cross-species communication in nature, perhaps the most surprising form of animal communication, is the one that crosses species lines. In nature, many animals have developed the ability to understand, and even respond to, the signals of others. For example, meerkats and hornbills sometimes forage together, using each other's alarm calls to detect threats. The benefit? Two sets of eyes, and two kinds of signals, watching for danger. Some species have gone a step further by creating symbiotic signaling systems. The cleaner wrasse fish performs a dance to signal to larger fish that it's safe to approach, not for a fight, but for a cleaning session. The bigger fish opens its mouth, allowing the wrasse to remove parasites. This mutual understanding is based entirely on learned signals and trust. There are even documented cases of animals learning human cues. Dogs have evolved to read human facial expressions and pointing gestures, something even chimpanzees struggle with. Dolphins in captivity have been taught to understand hand signals and visual symbols. In the wild, crows can recognize individual human faces and communicate this danger to other crows, passing down the knowledge across generations. These examples prove that communication isn't locked within species walls. Nature is full of unlikely partnerships and understanding. From warning calls to shared hunts, from alliances to mimicry, the animal kingdom shows that the need to connect, to be heard and understood, is universal. Animal communication is far more diverse and sophisticated than most of us imagine. What started as a curiosity becomes a revelation. Creatures around us are speaking in their own tongues, using sounds, scents, lights, vibrations, colors, and electricity. These messages are not random, they are targeted, intelligent, and, in many cases, emotionally driven. To ignore them is to miss out on one of the richest aspects of the natural world, a hidden language waiting to be decoded. Understanding how animals communicate reshapes how we see intelligence itself. We often measure intelligence by how much like us a species behaves. Do they speak, write, or solve human-style puzzles? But perhaps a better measure is adaptability, creativity, and the ability to send and receive meaning. By this measure, the animal kingdom is overflowing with brilliance, expressed in ways we are only beginning to grasp. This also has major implications for conservation and empathy. When we realize that animals aren't just acting on instinct, but communicating with awareness and purpose, it becomes harder to treat them as lesser beings. Protecting their habitats, respecting their signals, and studying their languages aren't just acts of science, they're acts of recognition. So next time you hear a bird singing, see an ant trail, or watch a dog respond to your voice, remember, that's not just behavior, it's language. And in the grand conversation of life on Earth, we are not the only ones with something to say. We just need to learn how to listen.